Hello students, welcome to Lab 4. In the last lab number 3, we did a couple of important things. First, we looked at recoding variables, that is moving from ratio level measurements and other high level measurements down to lower levels of measurements using the functions cut and if else. We saw those in action when we used them with mutate, for example, and we got a lot of mileage out of those two. Then we also learned how to summarize our data sets. We learned how to go from data sets with many rows down to data sets with fewer rows in ways that summarize what it is that we were doing. We did that by using group. We looked at within group counts, averages, and standard deviation. But really, you can use any method of aggregation that you think is relevant. And now you have the tools to be able to do that. And finally, in the last module, or in the last lab, we looked at new types of geomes and a couple new aesthetics. So we moved beyond just XY as the aesthetics that we were interested in, as the axes that we were interested in. We also looked at, for example, in your last homework assignment, the transparency of a given point. We also looked at the color, for example, and we examined a few new geomes like geome line, geome ribbon, other things like that. And finally, we looked at faceting. We asked ggplot to make several independent charts per each observation, unique observation in a given variable, and then put all those plots right next to each other, essentially. That's what we did in the last module. And with that, we're starting to get really close to you having a full toolbox that you need to do pretty much anything that you want to do in data analysis. You're almost there, and there's just really two more tools that you need, and one tool that's nice to have. And with these tools, with their creative use, with their application, you can pretty much accomplish anything it is that you want to do. So to kind of prove that today, instead of working with a pre-cleaned data set, we're going to work with actual data that comes essentially raw from the World Bank website. Right? So I've already downloaded these websites, so you don't have to sit here and watch me download it. But besides that, I've done absolutely nothing else to these data sets except for just rename the file. That's it, right? Because World Bank data is in a specific format. We want it in a different format, so we'll learn how to do pivots. We'll learn how to move it from one format to another. In fact, why don't we put this up here so that we do it in the right format, in the right order. Then we're going to learn how to do merges, because often it's the case that you don't just have one data set you want to explore. You have multiple data sets that measure the same unit, for example, a country at a given year, and you want to put all those data sets together, and you don't want to have to kind of manually do that, right? If you've used Excel, you might use VLOOKUP, for example. We're going to do the equivalent and far more powerful version of that, which if you've used SQL, you know as joins, but we're going to call them merges here for now, just as a general term. And with these two things, you will have all of the tools you need to do pretty much whatever you want with data analysis in R. Now you'll have to learn some of the nuances of how these functions work, and you'll have to get creative about how you use them, and you're going to have to kind of structure your thinking in a manner that makes these tools useful. But in general, you're not going to have to go find a ton more tools that help you accomplish what it is that you want to do with data once we've covered pivots and merges. After this module, we're not going to do any more of this kind of learning of tools. Will be done after today. And we're just going to be applying our stuff and learning other things like, how to make things look nice. Which brings us to our last topic for the day. You've noticed that we've done a lot of visualization stuff. We're going to continue doing visualization stuff because visualizations are cool and they should look nice. And so that's what we're kind of going to focus on today. How do I make my visualization look nice? How do I change the colors of a bar chart? And how do I tweak those aspects of my visualization that aren't kind of tied to data? Right? So far, we've really only focused on aesthetics. That is, we looked at variables that are mapped onto certain axes, but sometimes, for example, maybe I decide that I don't want that gray background with the white grid lines that ggplot automatically produces. Maybe I don't want grid lines at all, and so I can change that, but those changes don't have any effect on how the data itself is represented. And so these will go in themes. We'll also learn how to, for example, change the fill of my variable with scales. And scales really just say, for this aesthetic, use this nice visualization. So that's what we're going to do today: pivots, merges, and visualization. So why don't we get started? Oops. Clear that out. Let's clear that out. And let's clear that out. Okie doke. So I know today I'm going to use my dplyr library, of course. We're going to use ggplot, of course. And we're also going to use a library called tidyr for when we are pivoting our data set. And in fact, we have more than one data set today. We have 2 data sets. So why don't we go ahead and open them up and take a look at them and think about what problems, we might face when we read this data set into R. Well, first of all, so this is access to electricity as a percentage of the population. And I note that one of my variables is country name, and all of my columns are years. So, what I really want is a column for year as a variable, and then each of those should be like, for example, Aruba 1960, another row for Aruba 1961, Aruba 1962. This data is in the wide format. So we have a variable as column names. I don't want that. That makes it difficult to do things like plot line charts, and it makes my analysis more cumbersome. So we're going to have to change that. Another thing I kind of note is that there are all these rows before our actual data set starts. I don't actually care about any of these, right? I know the world development indicators. I know that's where this data came from already. And if I were writing a paper, I would write a sentence or two about that. But in R, I don't really need that. And again, this is something I might put in a report, but I don't need that. So what I want R to do is to ignore these first 4 lines when it's reading in this data set. And so remember, the reason we use R is so that other people can essentially just take raw data from someplace, follow all of the steps that we do, and then get the same results. What I don't want is to kind of go in here and like manually delete these rows, for example. I could do this and then save it like that, and it'd be easier to read in. But then other people might say, well, what else did you do to your data set? So let's find a way to address these problems in R. So I don't want to save it. Let's go ahead and go to our other data set, also from the World Bank, which measures secondary school enrollment, which I believe is everything after the 5th grade, though I might be wrong on that specific cutoff. It might just be high school. I'm not really sure. But secondary school enrollment. And we have kind of the same format. Again, we have years and column names. That's not good. Again, we want to skip the first 4 row name, or first rows, before we start reading in all of our data. Okay. So why don't we go to our R file, and instead of immediately assigning our read in object or read in data to an object, let's just start off with, we'll read CSV, and then I just want to see what my data looks like. So let's go ahead and read CSV, electricity.csv. More columns than column names. Well, that might actually be a function. Actually, let's comment this. Read in data. That might be a function of the fact that those first few rows were essentially just blank. So why don't we look at read CSV's documentation and see if we can find a function that will skip reading those first few rows. Oh, this looks promising. And the argument should be an integer, so we're going to tell read CSV skip equals some number, and the number of lines of the data file to skip before beginning to read data. So let's try that. I remember it was 4, so I'm going to say skip equals 4. And yeah, there we go. Now we're reading in data well, right? But we still have a few problems here. First off, I don't need these indicator names or codes because ultimately I'm going to save it as an object called electricity, for example. So why don't we go ahead and we can drop these rows with select minus. And remember, if I want to drop more than one thing, I have to put it in C parentheses, indicator dot code. And let's go ahead and run that, put a pipe at the end of it, so we just get the first 5 or 6 rows again. And let's run that and see what we get. Yep, okay, great. So we're starting with country name and code. And you know what, it doesn't look like there's any observations for 2021. And we have just this kind of blank column all the way at the end that I want to get rid of. You know, why don't we verify that 2021 has essentially no data in it? And it takes some time to measure these things, especially all around the globe. And yeah, pretty much no observations for 2021. So why don't we go ahead and we can drop also the 2021. And note that it's called X 2021. We're probably going to want to deal with that a little bit later. And I also want to drop the X column, right? So let's run that. And yep, we dropped those 2 columns. And now we're left with these 2, right? Note that I still haven't assigned it to an object because I'm not done kind of doing that initial munging. Munging refers to all those activities you do in the beginning when you're loading your data set, getting it into a good format. So I'm not done with my munging. So each time I run it, I just want to print out the first few lines to the console to make sure that I'm making good progress. I'm doing the things that I think I'm doing when I write this code. And that's a good kind of sniff check. Make sure that you're on the right path. Okay, so there's still a few new things that I want to do. For example, I don't like it when my variable names kind of have variable capitalization, right? I like things to be all lowercase. You might like it to be all uppercase. And I also don't like it when my variable names have periods in them. It makes it very difficult to use tools like regular expressions, which if you don't know what that is, that's totally no problem at all. But periods are also reserved characters in other languages like Python. And so, you know, if I ever decide to use this data set anywhere else, I'm going to have difficulty with that. So I want to rename the country name and country code columns. And wouldn't you know it, the function for that is called rename. And then I just need to put in the new name equals whatever the old name is. And since I have more than one, so I want to do country name and country code equals country code, right? So new name equals old name. I don't like the old name. I want it to be the new name. So let's go ahead and run that and see what we get. Yeah, perfect. That's much nicer. That's much easier to work with. Okie doke, right? Well, there's probably still one big problem left, and that is that all of my year columns start with the letter X, and I don't want that X there, right? Ultimately, I'm going to want these numbers to be values in a variable called a year. I don't want one column per year, right? I want one column per country, one for country code, one for year, and then one for the value, right? And so ultimately these are going to want to be integers. And so let's get rid of that X. So one way to do that, you'll notice, for example, that I could do it something like this, right? X 1972, or rather 1972 equals X 1972. So anytime I want, you know, R to treat something verbatim, I have to use these goofy apostrophes that you'll find on the tilde button, right? And I could do this for every single column, manually going through and, writing, 2017 equals X 2017, 2018 equals X 2018. But I might tear all my hair out if I do that. And I don't have that much to begin with. My father's bald, my grandfather's bald. It's coming for me. And so I don't have any follicles to spare when it comes to do that. So we need to find a better way of doing that. Luckily, the rename function is not our only tool. dplyr also allows us to do rename all, and you'll notice that one of the options is to do it with a function. So that's terrific. If rename, I'm sorry, it's called a rename with. Right? Likewise, we still have the functions observation. So what do I want to do here, right? Well, what I really want to do is use a function to transform the selected column names. And whatever function I tell rename with, it's going to do that for all of these things. And so since these start with X, I know that these are characters. It's going to treat these as characters. And so when I'm dealing with characters or strings, a good package to use is the string R or stringer package. Okay, so functions equals string replace, because I want to replace all of the X's, and the string is just all of the column names. I can put a dot here for that. The pattern is X, and my replacement is nothing, right? And we have to put a little tilde here. And let's see what we get. Yeah, we get exactly what it is we're looking for, right? Get exactly what we're looking for. And note that country name and country code didn't have X in these column names, so it didn't do anything there. Right? I said, well, I didn't find an X, so I didn't replace it with anything. Good job, dplyr. Nice, thank you. And now this data set is looking pretty good here. This data set is looking pretty good. But you'll notice that it's still not quite what I want, right? So let's just say, okay, we read in our data. Let's go ahead and go through and code this. We removed irrelevant variables. We renamed some columns. And then we fixed the year column names. Still haven't assigned it to an object, you'll note, right? But now might be a good time to do that. And just to go through rename with says rename all of the column names using this function. And this function, we start with a tilde, and the function I chose to use was replace this string. So for each column name, it inputted it, said, okay, boss, what pattern do you want me to find? And I said, capital X, please. And it looked through this column and it said, okay, I found one at the beginning of the name. And I said, okay, please take it out and replace that X with nothing. I said, okay, will do, right? And then we got our years in a nice format. Okay, so why don't we go ahead and we can assign this to the electricity object. And let's remember to remove this head function, because now we want all of them, right? And here's some good news, right? Whenever possible, you should steal your own code, right? If you've built this already and you know it works, then use it for other data sets that you know are going to work. So for example, if we try to read in secondary ed.csv, look at that. More columns than column names, the same error that we got the last time. And we know that all World Bank data sets, for the most part, are formatted in a similar manner. And so we can just copy from our previous data, and we can say, yep, that looks about right. Do we have all the same problems that we did last time? Yes. indicator name and indicator code are pointless that we don't need. So why don't we go ahead and steal from ourselves? We'll delete this pipe for now. And I kind of want to take it one step at a time so that I know that each step is still working. Sometimes data sets are very similar, but not the same. And so I want to make sure that I'm doing it right. Okay, great. We got rid of those. Next, I definitely do want to rename country code and all of that. So let's see if country name and country code, if that works. Yep. And now we can go through and we can rename with, oops, right? All of these variables still have the X variable in them. That's not terrific. So why don't we go ahead and we can see if that worked here too. And sure enough, it worked. Well done, right? This took us, with me talking about it, 15 minutes. This took us a minute, maybe, right? So we'll call this read in, whoops, education data ditto above functions. I'm not going to recode all of this. It's quite literally copying and pasting. So we'll just do this and we'll call it electricity data. So one nice way to organize your code is to do so in sections. So under your code, you can find insert sections, and we're going to call this the read in data section. So it'll put a nice header there. Why don't we save what we have and move on? Whoops. And remember, let's get rid of head, and we'll call this the education object, and we'll read that in. Why don't we view our education data set and see what other changes we might want to make? So I like this, right? Country name and country code are nice, well-behaving variables. They're in a tidy format, right? The column names don't contain information. They just tell us what the name of our variable is, and then our variable takes on different values here. The rest of the data set, not so tidy, right? Because the column names have information in them, and I don't like that. I don't like that one bit. What I really want is, we're going to call this the pivot section, pivot down data. What I really want is a data frame, and this is just an example, where I have one column for country. So let's Afghanistan, and you'll see in a second why I do Afghanistan twice, and maybe we'll do Iraq twice and Myanmar, right? Here's one, that's one column, and then I'll have another column for country code, or I'm sorry, let's just keep this simple. I'll have one for year, and so this will be like 1990, 1991, and then the same 1990 and 1991 for Iraq, and 1990 and 1991 for Myanmar. And then finally I want something like education levels, what was the education level for Afghanistan in 1990? Let's say 0.5, 0.75. What was the education level for Iraq in 1990? 0.5, 0.66, right, in 1991. And lastly, what was it in Myanmar? 0.25, 0.33, right? And these are all just obviously randomly generated numbers, but ideally this is what I want my data set to look like, or something similar to that, right? It doesn't look like that right now. It looks wide. This is the wide format of data, where we have variables masquerading as columns. I don't like that. This makes doing things like making a line chart, for example, very difficult and cumbersome, and I want to avoid that. So what I need is some way to keep these two things, these two columns the way they are, and to move all of these columns down into a long format, right? So let's call this example long format data. We have wide format data. We want long format data. So why don't we start off with education? Let's take a look. Yep. Okay. So what I need is some function that will move my data from wide to long. Luckily, I have functions from the tidyr library that we downloaded and loaded, earlier, that will do just that. So let's pick pivot longer, and to make it easier, why don't we pull up the documentation for pivot longer? Question mark, pivot longer. Okay, pivot longer lengthens data, increasing the number of rows and decreasing the number of columns. That's what we want. The inverse transformation is the pivot wider. So one thing to note is that not only will you get all of the functions here in the documentation, most of the time you'll get quite good examples as well. And examples that are kind of baked into R. If you go and you look it up online, you'll get even more details. So these are some tricky functions sometimes. But really what we need to know now is, first off, what columns am I trying to pivot into a longer format? Okay, so let's tell it. I want you to take the columns from 1960, right? That's the name of this column, to 2020. But I'm not done there, right? Because I'm creating a new column, right? What variable is captured by these values? What are these values of? I would say they're values of year. So why don't we run that and see what we get? Can't subset columns past the end. So what it's telling me is, sorry boss, there's only 63 columns here. There's no 1960th column. And that's because there are numbers as column names. So when that happens, we have to put them in these goofy little backstrokes. And let's see what we get. Yeah, no error. And we got exactly what we're looking for. We got one row per year per country. And though we didn't observe anything for that given year, right? We don't have any values in that given year. This is the format that we're looking for. This is pretty much exactly what we're looking for. But, you know, the term value isn't very informative. And so what I want is not just names to, but I want something like a values to. Yep, here we go. A string specifying the name of the column to create from the data stored in cell values. So why don't we, so basically it's just going to name this something else. So I'm going to say values to equals, and since it's education, I'm just going to call it education. Perfect. See? So why don't we go ahead and assign that back to the education object, because I don't have any more use for the original education data set. I'm never going to use a wide data set. And if I do, I can easily put it back with pivot wider. So let's go ahead and do that. And you'll notice it did exactly what it said it was going to do. It increased the number of rows dramatically, but it decreased the number of columns. And that's usually a good thing because R can handle millions and millions of rows, but has a much harder time dealing with thousands and thousands of columns. So we really want to think about conceptually what is a column and what is a row, right? And again, we can do pretty much the same thing to our electricity data set. So why don't we be code thieves and just do that. And instead of values to education, we're going to do values to electricity. And yeah, nice. That works pretty well, right? So we're just going to put this right back into electricity. And we're going to comment this and we're going to say pivot down education to long format. Pivot down electricity to long format. Okay, so we've covered pivots. You will soon find when you are looking through data sets, or perhaps in your careers, that people love their Excel files and they love putting things in wide format. When really, most of the time, we want it in long format. So this is an exceptionally useful tool, and you will probably use it, hopefully use it, when you do your final paper. So let's go ahead and move on. Now we have our data set in useful format, but we want to put them together. They're in two different objects. I want them to be in one object. So I'm going to say merging data sets. That's what we need to do. Let's take a look at education, and let's take a look at electricity, our objects, and see what we've got here, right? What we have is three variables in common: country name, country code, and year. And we have one unique variable, education and electricity, per object. This is a lot of redundant information, and more importantly, they're not in the same data set. So if I wanted to make a scatter plot of education versus electricity axis, I wouldn't really be able to do that, right? Moreover, if I hadn't found my second data set from the World Bank, maybe some of those values would be missing. You know, maybe a data set didn't measure anything for Aruba, so there's not even an Aruba row, or several rows for Aruba in whatever my second data set is. What I want is some robust way of merging my data sets together so that, for example, let's say I start with education. And what I want to do is to tell R, okay, for every single row of this data set, note that the country name is Aruba, the country code is ABW, and the year is 1960. Go find a row in electricity that has the same values for country name, country code, and year. And when you do that, you don't need to replace these rows or duplicate them, but whatever columns remain, make one additional column. So in addition to education, we should have electricity here as well. And whatever the value of that row is, of that variable is, for those rows that match, put that number here. One way for us to do this is to do a left join. Left join. So we already have our X, right? Remember, whenever we do anything in dplyr, it passes in our data as the first argument. And we want to join. Let's go ahead and pull up the, this is what we're doing, right? We want to have one row for every row in education. So what we need to tell it now is, okay, what's the other data set that you want to merge on? We can say, well, I started with education, so I want to join on, or I want to join to electricity. And I want to join by these variables: country name, country code, and year. And let's see what we get. Object country code not found. Okay, let's try putting these in quotation marks and see what we get. Perfect. Perfect. With one line of code, we merged two data sets with over 16,000 observations together. And now we can map it in any way that we want to, right? We can actually do data analysis here now. So that's it. Left join. You'll notice that there are other types of joins as well. Since our data sets are both from the World Bank, we know that each row in education is also in electricity, but that might not always be the case, right? Especially if we're merging across different data sets produced by different organizations or produced by different people, then there might not be such a one-to-one match, right? Here, it's a little bit easier. There was that one-to-one match, but there's not always going to be that one-to-one match. And so when we do that, maybe we can say, okay, only keep the rows where there is a match for both, right? Only keep the rows that do match. And so why don't I go ahead and I'll call this my final data set. Whoops, that's a typo. Nice. And why don't we go ahead and remove some clutter. I can remove education and I can remove electricity. And now we just have the one data set that is much easier to work with, right? We've put our data sets together. We have two of our variables together here. And again, it's worth noting, all of these are different chains, but they could have been all just one big chain, right? For example, let me just show you as an example. One big chain, right? Let's say that I just wanted to do all of this stuff all at once. So let's start with our secondary education data set. And we had one kind of code chunk here that read everything and made it nice. But, I mean, we have the pipe operator, right? Why stop there? It's our education data set. So why don't we just go ahead and copy in our pivot? Yeah, perfect. Why wouldn't I do that? Right? Well, because I'm teaching you all how to do that, and that might be a little bit cumbersome, so we take it one step at a time. But when you write your code, there's no reason you can't do it this way. Right? Why not? Save space. So we can do it in one big chain. I'm going to delete that for now, but know that you absolutely can do that. Okay, so we have now covered merges, and I will link to a video that goes over the logic of merges. It's in the context of SQL. If you're used to SQL, merges will be nothing new to you. But if you're not used to SQL, then the logic of joins and merges will be new to you. But this is the video that I'll link, is kind of the most intuitive explanation that I've found that doesn't take like 4 hours of some YouTube video of some person like lecturing at you about what a join is. It's a little bit corny, but I found it to be a really good explanation of what joins are. So, okay, we've done that. We've pivoted our data. We've fixed a whole bunch of columns. We merged our data set. Let's go ahead and get to the visualization aspect. So let's add the visualization. Why don't I choose just one country? So I'll just pick Aruba this time around. I'll put it in a visualization called a viz, and then filter to N countries. Because we might come back and we might add more than one country here, right? But for now, let's just keep it the way it is. And then I'm just going to do something like data equals viz. For my aesthetic, I want X to be year. I want Y to be education. And then why don't I try just making a geom point and see what we get? Excuse me. Yeah, that looks about right. There are a whole lot of kind of missing values. So, you know, maybe what I'll do instead is I'll just drop NA values. That is, drop any rows where the values are missing here. And before I assign that back to my viz object, let's see what we get. So pretty much from 1999 to 2012, I get continuous data. Yeah, that looks good to me. Let's do that so that we're working with a little bit more of a robust time frame. Visualize my data. Okay, right? And, you know, this is time series data. So why don't we add a geom line? Each group only consists of one observation. Do you need to adjust the group aesthetic? I think I do. So the group tells ggplot. For example, maybe we have multiple countries. In this example, we don't. But often we will. Often we will have multiple countries, and we'll need to tell ggplot how to connect the lines. Right? So we'll say group equals country name. And that figures it out for us, right? Okay, so there are a couple things that I really don't like about the way that ggplot plots things. Some of them are quite ugly, for example, right? One thing that I really don't like is I really don't like these little axis ticks. For whatever reason, they just super get on my nerves, and I think they look really ugly. Call me crazy, but I think most people have the visual capacity to just follow these lines up and see where they intersect with the points. I don't need to hold people's hands that much. But I don't, that's not really a part of the chart that's data driven. And so there's nothing in aesthetics or the home ggplot command that might change that. Excuse me. What I'm looking for is some thematic change. And so in my theme command, I'm going to say axis ticks equals element blank. And that'll get rid of all of my axis ticks. Notice that there are no axis ticks down here any longer, right? The functions that go in here handle all of the kind of superficial aspects of this chart that aren't related to the data itself, right? So let's go ahead and let's do something else. We'll do panel background. And the panel background is an element of the chart that is a rectangle. And maybe I want to change the fill to red. Nice. I want to overwhelm my viewer with the majesty of my line chart. Let's go that extra mile and let's change the color of geom line to green. Oh yeah. And make it extra bold too. Size equals 5. Yes. Nice. Visual design is my passion, right? Okay, so really kind of the point is you can change it to be whatever you want, right? These visual aspects of your aesthetic, the visual aspects of your chart can be changed. Even those parts that don't specifically deal with the aesthetics, you can, right? You can probably go online, or actually not probably, you definitely can go online and you can find pre-made themes that mimic the themes used in major publications like, you know, the Washington Post, the New York Times, 538, or The Economist, for example. All of these are available to you online, and you might find that you like certain parts of your chart to look certain ways as kind of a consistent personal brand, if you will, right? So for example, I have my own theme that I usually load when I'm doing my own projects that I like to just carry across my projects. It's kind of a visual statement. I like the way it looks. And when people see like the color scheme, for example, they say, okay, all right, Haroon uses this in all of everything that he does, right? Let's go ahead and get rid of this for now, because I'm not a masochist, and I wouldn't do this to you. But let's go ahead and let's just do the same thing we did with our last line chart. So let's go back for a second and let's say, okay, I don't just want Aruba. I want more countries than Aruba. And since I want that, right? Well, we've done theme, right? And note that theme handles pretty much any visual aspect of the chart that you can think of. You can find it in theme. Just look up theme components of ggplot. So let's go back to our data set here real quick. Aruba, Afghanistan, and now our visualization has more than one country, right? So let's go ahead and plot this. Again, we told it what group, and let's plot that, see what we get. Yeah, we get 2 lines, right? But we don't know which country is which. Which one is Afghanistan and which one is Aruba? Well, all right. Well, there's a couple things we can do. We can tell ggplot, you know what, why not change the color of the line and the dots by the country name? And let's see what we get. Okay, now it gives me a legend. And you know what? Part of the theme, one thing I can do is I can put the legend at the top of the chart. I think that looks a little bit nicer. Maybe it's just me. And I don't think legend titles are all that important. So I'm just going to get rid of the legend title, right? People understand what that means. I don't need to tell them that that means country, right? And it unsquishes the chart a little bit. So that's good, but I'm really not fond of the colors that it chose. It always chooses, whenever you have 2, it always chooses this like teal and this pink salmony color that are, well, let's call them distinctive. Let's say ggplot selects distinctive colors, and I'm not fond of distinctive colors. Instead, I want to change those to some other palette that's a little bit nicer. So I don't do this in theme. I need to do this in some other argument that references an aesthetic specifically, right? Because we mapped country name onto color. We've mapped this aesthetic. Now we need to fiddle with the function that assigns country name to a specific color. And we just need to fiddle with the color part. So when I need to fiddle with a specific part of an aesthetic, I say scale. What aesthetic am I fiddling with? Color. And let's just say I want to manually choose my colors. I'll say manual. And then let's say I also want to manually choose the values of my colors. I'm going to say values equals, and let's do red and blue, just to keep it easy. And let's rerun that and see what we get. And sure enough, I get red and blue values. If I had 3 countries, Aruba, Afghanistan, and Myanmar, what would happen? Well, I would get an error. Insufficient values in manual scale. 3 needed, but only 2 provided. Well, yeah, because I got red, blue, and now I need a green for that 3rd country, right? I have 3 countries in my data set. I need 3 countries here. Let's rerun that. And yeah, we get our 3, right? I don't know about you, but I'm actually not very good at picking color values. And instead, I know that there are a handful of color palettes that other people have already put together that are pretty nice, right? So why don't we just use those instead of manually filling them in, manually picking those colors? So maybe I'll go scale color, and I'll use the Viridis color scale. And it looks like there are a lot of scale viridis. So why don't we just choose one, and we don't have to tell it anything beyond that. We'll comment out this manual scale, and let's see what happens. Scale only supports manual, or I'm sorry, bin to scale only support continuous data. Oh, so that B wasn't random, and I should have read the documentation. I have a a discrete variable, and so I'm guessing that I need the scale color viridis D argument. And yeah, sure enough, right? Now the viridis is a little bit nicer. I don't know, that yellow is kind of an eyesore, but in general, it takes the thinking that I have to do about picking colors out of the equation. So that's nice. Lastly, color isn't the only scale that I can mess with. For example, let's go back to our axes. So I have an axis on the X, and I know that that axis is continuous, right? Numbers are continuous. And maybe I want to expand or contract this chart a little bit. Maybe I'm only interested in the period where all countries had observations. So maybe I want to say, okay, the limits of this chart, I want you to clip them to 2001 and 2012, right? Because 2001 was the first year we had data for Afghanistan. 2012 was the last year we had data for Aruba. So let's rerun that. Discrete value supplied to continuous scale. Now I'm starting to think this is a problem with our data. And yeah, look at that. Our year variable is a character, and we definitely don't want that. So why don't we go back here? So this is a problem of our data having the wrong type. The class of our data is incorrect. So what we need to do is to say year equals as integer year. We just need to change the class of the year variable. So let's go ahead and rerun that. It looks like it ran pretty well. So I'm going to assign back to my viz dataset. I'm going to rerun my plot, and it runs really well, right? It did exactly what I asked it to do. But you'll notice that now all the years look kind of goofy, and I have some red text here. First off, this is a warning, not an error, right? So it's just telling us, hey, just so you know, I'm not showing several points in the viz dataset. And I would say, yes, I know that, because I knew that there were more points out here for Myanmar and Aruba, and I didn't want you to plot those specifically. So this warning for us this time, that's okay, no problem. Another problem though is that my marks aren't good. I don't like this. Not a fan. I think what I really want is still one tick on my axis for every year observation, or maybe I'll do every other year observation. So why don't I go back to my scale x continuous argument, and I'll say my breaks should be in a sequence starting from 2001 and ending in 2011, and I want you to take that sequence by twos. So I want one break for 2001, 3, 5, 7, 9, 11. Let's see what happens. Yep, that's what I get. And that's much nicer, because when I'm looking at years, I don't want to look at 2010 and a half. I want to look at integer number years. Lastly, I think I want a title. So we've done that before, no problem. And let's go ahead and get rid of this manual one. Let's go ahead and add a title. Education levels for countries My x-axis, whoops, let's call this title. The x-axis should be year capitalized, and my y-axis is secondary education level and plus. Whoops, error in title. Plot new has not been called yet. What did I do wrong here? Oh, whoops, it should be labs. Yeah, and you know what? I tend to like my titles in the middle. So let's do plot title, and it's a text element, and I want it to be right in the middle, horizontal justification of 0.5. Okie doke. And if I wanted to change the font of that, I could do that as well, right? So though we didn't do anything really data driven with our plot this time, you know, one new thing that we did that was data driven was that we have like multiple lines, for example, on our line plot, and that was only possible because we pivoted and merged our data set. If we hadn't pivoted it down, we would have to have like a million geom point calls, one for every observation, and that would be pretty much just the incorrect way of doing things, right? So we munged our data until it was good, until it was in a good format, and then we built up our visualization until it looked very nice, right? We picked a nice-ish color palette, we changed the breaks of our years, we have a nice title that is now centered, and I could just copy paste this into a report if I wanted to do that for a final paper. That would be totally fine. This is good to go. There's nothing wrong with this at all. So why don't we recap for the day and we'll see what we did. First off, we read in our data sets, and as data is most of the time, our data was messy, right? So we had to do a few things. We had to drop irrelevant variables, we had to rename some columns, and we had to get a little fancy about how we rename some of our columns with rename with. But once we did that the first time, we could just do that another time. We just copied our code essentially and did it for the other data set as well. Once we did that, we looked at changing the format of our data set from wide to long. So we did that with the pivot argument, or the pivot functions. And we did that for both education and electricity. Then we talked about merging our data sets. So we just have one data set instead of two data sets, right? And we made sure to tell R, hey, only match rows where these variables match, right? That's the power of the join. We don't have to worry that we've arbitrarily made some sort of mistake. If anything, mistakes are kind of, if there is a mistake, then it'll be that you match too few rows, not too many rows. That's the power of joins, right? And then we removed our old objects because we don't need them anymore. And then lastly, we did a few nice things to our visualizations. At this point, we're getting a little bit more comfortable with aesthetics, with geomes, and we might want to start fiddling with, you know, the nice looking aspects of our chart. So we did things like change the color. We used scale color viridis for our discrete scale. So it picked colors out of the viridis color palette and it assigned them to country. We changed our x-axis, the ticks. We got rid of some ticks. And what else did we do? Oh yes, we messed around with the title and we put our legend at the top of the chart instead of at the side. So that's what we've done for today. I know our last assignment was a little bit more challenging and really required you to kind of hopefully go dig around and learn new ways to use the functions you already know about. I'd like to give you a little bit of an easier week this week, so your homework assignment will not be quite as challenging as it was last week, but hopefully you're still using all of those skills and the tools that you used and are starting to transition into thinking about your final paper. Do not put your final paper off. It's going to take you time to munge with that data, so start applying the skills that you use every week in these labs. Start thinking about the concepts and other things that we do in the lectures, and I'm looking forward to seeing your homework assignments. Good luck, and if you are struggling with anything, give it time, help each other out, come to office hours, or just email me. All right, good luck.